Okay, I'm glancing at number 40. Same deal, a plus. Needs to add. So a 5 and a 5 are the closest factors, 3 and 3. I need them to add up to get me 30. 15 plus 15 is 30. Guess what? 5. And you notice the first has a variable. Automatically you could write that in, the next doesn't. So either you write it this way, which is fine, or you could simply say that is 5x plus 3 squared. Either or, it really doesn't matter. So let me run those down really quick. How about here? The same deal. I look for greatest common factor. I noticed that 16, 72, and 81 is a bunch of 3's. That doesn't work. So closest factors of 16 is 4 and 4. Closest factors of 81 is 9 and 9. I need them to add to get me 72. 36 plus 36 is 72. To get negative, they're both negative. And this turns out to be 4, and there's an x there, minus 9. And do you notice there's a y squared? So basically, you could write it this way, or you could say that is 4x minus 9y squared. Same deal with 44. You look for greatest common factor. There isn't any. 2 and 2. Closest factors 3 and 3. 6 plus 6 because you add. That works. I want a positive, so make them both positive. That's really simple if it's a plus. So that's twice s plus 3. And do you notice there's a t squared? And you could just say squared because they're the same, as you notice. Now, what happens if it's a minus? Same idea applies almost, except the same process. Instead of adding, now you subtract. Factors 1 and 1. Closest factors of 40 are 8 and 5. Subtract to get me 18. Well, 5 minus 8 is 3. That doesn't work. 10 and 4. If you subtract those, that gets me 6. That doesn't work. Okay, what else? 20 and 2, right? 20 minus, so I'm going to erase the middle part. I'm going to write this a bit bigger. So this worked. 20 and 2 seem to work. They multiply to give you 40. If you take 20 minus 2, that works perfectly. So the 1 and the 20 and the 1 and the 2. If it was a plus, they both have the same sign. That's easy. Here, I want a negative 18. Doesn't that mean that 20 must be negative and the 2 must be positive? So the 20 must be negative and the 2 must be positive. The first has a variable, and pretty much you're done. Versus if this was positive 18, you would have had to switch those signs. Same deal here, no greatest common factor, but I notice that's 2 times 1 and 6. I could say 6 is 3 times 2, 2 times 3, or I could say that's 1 times 6, 6 times 1. I need them to subtract to get me 11. 4 minus 3 doesn't work. 6 minus 2 is 4. That didn't work. 12 minus 1. That works. 12 minus 1. How do you get a positive 11? If you had a positive 12 and a negative 1, right? So the 2 and the negative 1, 2x, of course, minus 1, and an x plus 6. And that's how you start factoring a bit faster. 7, 43, nothing in common. 7 and 1, again, subtract to get me the 43. Obviously, I need the number to be big, because that's really big. If this number is small, then I want it to be small. And that's kind of how you start really playing with this. So if I look at 42, I could say 6 and 7, right? 49 minus 6 is 43. What do you know? There it is. I want a negative 43. So I want a negative 49, because that's where the 49 comes from, and a positive 6. So if this is negative, they always have opposite signs. 7 what? 7x, a plus 6, and an x minus 7 will do. So the 7 and the 6 are right there, and the 1 and the negative 7 are right there. Here, I notice on number 38 there is something common. They're all even. I could take a 2 out, but I notice that's a 40, that's a 34, I could even take a 4 out, maybe more. 80 divided by 4 is 20, and 4 divides 6. 4 divides 6 one time, you have 24 left. 4 divides 18 6 times, and 4 divides 40 10 times. That means I could take another 2, making that an 8. If I take a 2 out of that, that'll make that 10s squared plus 8s minus 5. And now we need to see if we could factor it even further. Factors of 10, that would be 2 and 5 the closest. Factors of 5, 5 and 1, 1 and 5. I want them to subtract to get me an 8. So if I go for 25 minus 2, that's not going to happen. 10 minus 5 is 5. That didn't work. The 2 and the 5 are exhausted. If I go, we exhaust all the possibilities, 1 and 10. If I go for 1 and 5, 5 and 1, that would be 10 minus 5. That didn't work. And 50, basically, that's all there is. This only has a greatest common factor. Remember, if you can't factor it, you have to exhaust all the possibilities, which is a lot of work. And if I proceed, now I'm looking at this, and this happened to be 2 terms. Well, 2 terms, I see a 2 I'm aiming for. Can I make those perfect squares? What do you raise to the second power to get 121? 11m. What do you raise to the second power to get n to the 6 n cubed? And now you would write them twice without those squares. The 11m and the n, 11m and the n, 1 time minus 1 time plus, I'm sorry, the n cubed. And pretty much you're done. If I look at this problem, I say, okay, well, I see that this is even, so I aim for a perfect square if I can. What do you raise to the second power to get 16? 4q to the 4th. And here 5r, and you would write them without those squares, so the 4q to the 4th and the 5r, the 4q to the 4th and the 5r, 1 time minus 1 time plus. I didn't mention, but I am doing that. You're always looking for a greatest common factor first. If I look at the next problem up, number 50, so it seems I have to adjust those slightly. I'm going to move that down here. This way I have more space. And let me push this up a bit. Again, lining up is always a bit of a challenge. And if I move this right there, here we go. Again, I see one of them being squared, so I should know I'm aiming for squares if possible. What do we raise to the second power? Well, 3p squared. And here, for w, you would write them without those squares, the 3p squared and the 4w, the 3p squared and the 4w, 1 time minus 1 time plus, and that does it. The reason I'm not going on any further because I can't, because this w is not a perfect squared. Here I'm looking at cubes, and if you recall, for cubes, this is how it works. You would write this without the cubes. Well, let's see, or not without the cubes. You would think of 1 is a tricky problem because you could raise 1 to any power and you will get 1. So if I want to figure out what is 216, I know it's not 4, 4, 8, 4, 16, 64, it's not 5, it must be 6. So that's 6x and a 1. And remember, the cubics are a bit messier. If you recall the cubics, you write it without the cubes. So you would write them without the cubes. 6x plus 1. You would square the first. You would square the last. And you would multiply those. the last is always positive. This sign is always the opposite of that. That's how I always memorize it from when I took this ages ago. I get to number 56, which was supposed to be next. Let's do that next. And on 56, the same deal. I'll say, well, let's see. What do you raise to the third power to get a 27, 3w, and a 1? And you would write them without the cubes, without those cubes. The 3w plus 1 as you see it. You square the first, 9w squared. You square the last, and you multiply those. That's 3w. The last is always positive. This is always the opposite of that. That's my answer. I get to number 58. I try to factor, nothing factors out. The fact that one of them is a 3, I would know. Squares don't work. What do you square to the third? What do you use to the third power to get s to the 6? S squared t, and a 125, 5u to the what? 4. So you would write them without the cubes. That is s squared t minus 5u to the 4th. You would square the first. That is s to the 4th t squared. You would square the last, 25u to the 8th, and you would multiply those. That is 5 s squared tu to the 4th. This is always positive. This sign is always the opposite of that. Looks really messy, but that's what it is. And if I take number 60, and say, well, look, that's a perfect cube. So I could say that's 2r minus 3s cubed plus, what do you raise to the third power to get t to the 9t cubed? So without the cubes, you write them once. This is a bit messier than usual. And you square the first. You square the last. You multiply those. The last is always positive. This sign is always the opposite of that. You don't need to clean that any further. That's fine. And I did notice there was one more problem left. That's the last problem we're going to do in this section. If I take the greatest common factor, none. So what do you raise to the third power to get 343? 7. Let me see. Is it 7? Let me think really quick. 721. 7 times 7 is 49. Yeah, 763. That works. 7 t z squared cubed minus and 4s. And what would that be? Without those cubes, you would write 7tz squared minus 4s times, square the first, 49 t squared z to the 4th. Square the last, 16s squared. Multiply those two. That is 28 t z squared s. The last is always positive. Be careful. This sign is always the opposite of that. And these, even though that's 3 terms, that's always prime. And let me give you the homework. And the homework is section 1.5, page 62, number 1 through 61, odd. I did all the evens right now. Or you could do every other odd, in case you don't know what that means. 1, 3, 5, 7, 9, 11, 30. Those are the odds. If I assign every other odd, what you do, you skip every other problem. Okay? And you go on. If you're really comfortable with factoring, every other odd will do. But if you're not, I strongly suggest you do the odds. I'm assuming after this section, you know how to factor.